So electric dipole. Electric dipole is a combination of two equal but opposite point charges separated by a small distance. For example, if this is one positive charge and this is one negative charge, and they are separated by a very small distance, then they constitute, and this is positive charge and this is negative charge, and the distance between them is like the distance between them is 12, and this is plus q and this is minus q, then they constitute an electric dipole. An electric dipole is a combination of two equal but opposite point charges separated by a small distance. Okay. Now, as it is a dipole, it has a moment. So, what is dipole moment? So, dipole moment is the product of the magnitude of either charge and the distance between them. In our case, since the distance between them is 12 and both the charges are magnitude of the charge is q, so the dipole moment represented by E vector, dipole moment is a vector quantity, E vector is equal to q magnitude into 2L, magnitude into 2L. Now L is a vector quantity, okay. L is a vector quantity. That's why I have written here 2L as vector and Q is a scalar quantity. So this is P vector is equal to Q into 2L. E into 2L. Okay. Now, field intensity at a point on the axis of a dipole. Now let there be two charges plus Q and minus Q separated by a very small distance 2L. Okay, and O is the midpoint. O is the midpoint, and this point, suppose plus Q is at point A and minus Q is at point B, and we have at point P, which lies on the axis of this dipole. This position is known as the axis of the dipole. On this axis, we take a point P at some distance. Let the distance be R between O and P. This distance is R. So we have to take a point on the axis of the dipole, which is at a distance of R from the center of the dipole. Okay. Now, if we want to calculate the field intensity at this point P, what we have to find out? We have to find out the net force acting on the unit charge placed at this position. Right. We have to find out the force or the net electric field which is acting at this point. So now both plus Q and minus Q will affect the electric field at this point. So field intensity at P due to plus Q, field intensity at P due to plus Q, field intensity at P due to plus Q charge. What it will be? Field intensity at P due to plus Q, it will be 1, since plus q and this is plus positive charge, so it will repel this charge, it will affect the repulsive force. So E1 is in this direction along OP. The direction of E1 is in this direction along OP. Okay. So E1 is equal to 1 by 4 pi epsilon into Q by, now the distance between this point A and P, distance between AP is, distance between OP is R and this is half O, since O is the midpoint of AB. So this distance between AO is L. So we can write R plus L whole square, R plus L whole square. So this is the force E1, right? And due to minus Q, force due to minus Q, E2, what will be E2? force due to minus q. Since it is a it is minus and this is positive, so it is an attractive force. So this place E2 takes place in this direction. E2 is directed towards this direction. Again, this is 1 by 4 pi epsilon into qy, and distance between this and this is dp. dp is OP minus OB. What is OP? R minus L. R minus L. So this is R minus L whole square. Now you may see that since R plus L whole square is greater, so E1 is less than E2. So E1 is less than E2. R plus L whole square is greater than R minus L whole square. So E1 is greater than E2. Now since E1 is greater than E2, therefore net is E1 minus E2. Net charge is E1 minus E2. So what is E1 minus, sorry, E2 is greater, my mistake. E2 is greater than E1. E2 is greater than E1. E2 is greater than E1 because R minus L whole square is S. So E2 is greater than E1. So net force is E2 minus E1. And E2 minus E1 is given by Q by 4 by epsilon 1 by R minus L whole square minus 1 by R plus L whole square. Now this gives you, if you do the mathematics, it is Q by 4 pi epsilon, and this is 4 into R L divided by R square minus L square whole square. R square minus L square whole square. So this is the expression, and now as we know that from dipole moment P was equal to Q 2QL, P was equal to 2QL magnitudinally. So here we can write P into R. 2QL we have represented by P. So 2P vector R divided by 4 pi epsilon 0, 4 pi epsilon, and divided by R square minus L square whole square. So this is the expression for the dipole moment or the field intensity at a point on the axis of a dipole, right? This is the expression for the field intensity at a point on the axis of a dipole. Now, suppose if the point P is very far away from this dipole, is very far away from this dipole. That means R is very much greater than R is very greater than L. So if R is very greater than L, so this R square minus L square to the power whole square can be represented as only R square. So the expression will become 2PR by 4 pi epsilon into R to the power 4, and if you cancel the R to the power 4, R gets cancelled and it becomes R cube. So another expression is 2p by 4 pi epsilon R cube, 2p by 4 pi epsilon R cube if R is very greater than L.